Hello and welcome to CCAG's August public meeting. Now, as summer begins to draw to a close in the global north, we reflect on the intense temperatures, droughts, wildfires, and floods that have dominated the past few months. The reality is that extreme weather is occurring more regularly and in more parts of the world than ever before. On our current trajectory, this is just the beginning. This is a climate emergency, and we must take urgent actions to meet the challenges it will bring. Today, we're going to focus our attention on extreme weather. That is how it can be managed going forward and what we can do to prevent it from getting even more extreme in the years to come. Joining our panel of scientists today, we have climate activists John Paul Jose, Nyombe Morris, Zaya Tong, along with Deputy Director at the Centre for Climate Repair, Professor Hugh Hunt. We're also delighted to be joined by a special guest, Professor John Stott from the Hadley Centre, the Met Office's Nerve Centre. Now, Peter spoke to our chair, Sir David King, a few days ago about the recent extreme weather events that we've experienced here in the UK.
So hello, I'm Professor Peter Stott from the Met Office Hadley Centre. And with the context of this summer very much in mind, with 40 degrees recorded for the first time in the UK, and with droughts, flash floods and fires across the continent, I wanted to present a couple of graphs that look at how rapidly temperatures are changing across Europe. And the first graph is showing us European summer temperatures from 1850 onwards. The warmer years are shown with red colours behind them, the cooler years with blue colours. And I've also marked on the years of 2003, 2006, 2010 and 2021, which are under the red arrows there. And in fact, these years were all at the time record warm years. The 2003 heat wave was a particularly notable event because it was by far the hottest year in the record and is also associated with over 70,000 people perishing in the heat. But you can see how that heat wave of 2003 was underneath the first arrow there, was succeeded by 2006, which had very similar temperatures. But then in 2010, the temperatures were much warmer, hotter again. And then in 2021, hotter again. And then when we have all the data for 2022, it looks likely that 2022 will probably be about as hot, if not hotter, than 2021. And also you can see from that graph, based on the observations of European temperatures, how rapidly temperatures have been increasing over recent decades. Now, back in 2004, I published a paper analysing the 2003 heat wave, and we showed that the risk of that heat wave had been very significantly increased by human-induced climate change. That was the very first study to make a direct link between an extreme weather event and climate change. And in that paper, we also made a projection of what could happen to European temperatures in the future. And actually what we've seen play out since then, as you can see on this graph, was a continued warming and a continued risk of extreme temperatures. And if I go to the next graph, you can see how this is played out compared to the climate model projections. So these are now updated model projections based on the very latest models, the so-called CMIP6 model ensemble, and they're shown with the red lines, and there are many, many simulations there. In the black are the observed temperatures that I showed you in the previous graph, and then the yellow line is the average of all those many, many climate model simulations. And what you can see there is that the increasing temperatures in Europe over summer have been very accurately simulated by those model projections. And indeed, just what we said back in 2004 is playing out. And in most particularly, that you can see if you trace your eye back to the 2003 temperatures spike, you can see that what then, 2003, was a very exceptionally hot summer has now become really quite a normal summer in our changing climate. And also what we predicted back in our 2004 paper is very much coming to pass, that in fact, such summers, which back in 2003 were so exceptional, are set to become actually cooler, not hotter summers. Now, these projections that I'm showing here with these red lines, where the average over all the simulations is in the yellow line, are making an assumption about future emissions. This is a so-called intermediate emission scenario, which assumes continued emissions where global warming reaches just under 3 degrees relative to pre-industrial levels by 2100. Such a future could be avoided if the Paris goals to keep global warming to well below 2 degrees are achieved. But even then, we would still have to adapt to summers, what would have been extreme summers in Europe in the past, where we are seeing, for example, heat waves, the floods and droughts that we are seeing indeed this summer. So there is this rapidly changing climate. I'm showing in Europe here, but of course elsewhere in the world, as we've seen this summer, is playing out, which we will need to adapt to. But some of the very, very worst effects could be avoided if mitigation is successful and the Paris goals are achieved.
And Peter joins us here today. Peter, welcome. It's great to have you here. Before we get into our guest questions, we wanted to ask Sir Dave to say a few words on why this data is so important in advancing CCAG's reduce, remove and repair strategy. Sir Dave, over to you.
One of the challenges that has been made in the past about the predictions made by this remarkable model that Peter has described to us and the results from it is that this is just a model. But here we see that if we go from 2000 forward in time, where the model was originally predicting forward in time, that we have a remarkable agreement between what was predicted and what has happened to 2021. The yellow line, that average, is very close to the black lines that we saw. And this really gives us...
So hello, I'm Professor Peter Stott.
I think...
Carry on, Sir Dave, carry on.
This gives us much more certainty in the model. The model is quite remarkable. It puts together a long-range weather forecast and temperature forecast out beyond 2100, but it also links in with the Meteorological Office's model, which predicts tomorrow's weather. So it's a completely comprehensive model and predicts for the whole world and every part of the world what the future is going to look like. Can I also just comment that Peter and I have discussed the possibility of his doing what he's done here for Central Europe, for the Indian subcontinent, for China, for Brazil. We're prepared to go around the world to see if we can get similar correlations and what the conclusions are from that.
Thank you, Sir Dave, and also thank you, Peter, for that insight. I mean, the stark reality of the trajectory that we're on is there right in front of your eyes. We can't deny it. The stats, the facts are there. You know, we're seeing it in the UK climate. And this is what this live stream is all about. This is what CCAG is all about, is to provide you with the answers. Now, Peter, please feel free to volunteer to answer any of the questions that our guests have for our panel today. I'm sure you are more than equipped to handle any of those questions, and your contribution will be very, very much welcome. So let's kick off with our questions then. And as is normal, or as is our normal way, I'm going to invite everybody to ask just one question to the panel first. And then if we have time at the end, we'll come back round for the follow-ups. So first of all, I'd like to turn to Zaya Tong. Zaya, it's your first time with us, so welcome. It's really great to have you, and we'd love to hear more about your view on today's topic of extreme weather, and also your question for the group. Zaya.
You're on mute.
Hello, Zaya. Just unmute yourself. Thank you.
I can't believe I fell for that trap.
That's all right. That's all right. We're now calling that the Sir Dave King mode.
Is it really? Well, I'm in good company then. It's great to meet all of you. I'm Zaya Tong. I'm a science presenter and author, and I also serve on the board of directors of WWF International. So I guess I really want to thank all of you, first of all, because I try to pay attention to CCAG as often as I can. And it's a really wonderful forum that you've put together, having all these scientific experts that we can pose questions to. So it's terrific. In terms of my own research interest and background, I'm really interested in perspectival shifts and also changing mindsets. So I wrote a book called The Reality Bubble, and it looks at 10 of humanity's biggest blind spots. And one observation that I made is that in the 21st century, there are cameras everywhere, except where our food comes from, where our energy comes from, and where our waste goes. So it's rather peculiar that we're the most powerful species on Earth, and yet we are blind to how we survive. So perhaps that lends itself to my first question, which is perhaps a blind spot within the environmental community. We know that hydroelectricity is a great form of green energy. We don't release the CO2 that is very, very dangerous. I'm beaming to you right now from Toronto because of hydroelectric power. At the same time, we've seen with extreme weather, with climate change, that we're seeing droughts all around the world. So whether we're looking at the Colorado River and the impact on Lake Oroville and Lake Mead, Lake Oroville, for example, shut down its electricity generation last year, or all the way to China, seeing what's happened with the Yangtze River, which has been jaw-dropping for everybody, and also noting that their water levels have decreased by about 50%. So in Sichuan province, the lights have dimmed on all of the buildings, and supply chains are being impacted because factories are shutting down. So knowing that we're only at 1.2 degrees, perhaps some say 1.3 degrees now above pre-industrial levels, and that this drought situation may be exacerbated into the future, what role do you see hydroelectricity playing in the future when it comes to renewables? For a long time, it's been a pillar of renewable energy, but we also have to contend with things like methane that comes from the dams, and also the impact on fish and wildlife. So I know it's a thorny question, but I would love to get your thoughts on how you see the future of hydroelectricity given the extreme weather and the extreme climate changes that we're facing.
So there was a little bit of background noise there. Could you repeat that last question again, please?
Sure thing. So the last point, or the last question, is really, given that we know that droughts will likely be exacerbated in the future, what role do you see hydroelectricity playing in the future? Should it remain a pillar of the renewable energy, especially given what we know with the methane release, which is much more potent of a greenhouse gas that comes with the dam formation, alongside the impact on fish and wildlife? Thank you.
Thank you. Great question, Zion. Thank you for that introduction. Christoph, I see you have your hand up, and Tiro, you can go afterwards. So yeah, let's begin with you, Christoph. No,
Thanks
don't
very
tell
much.
you yourself. Come on.
And thanks, Zaya, for the question. I think we should start by recognizing that all forms of electricity have their pluses and minuses. Whenever we're thinking about the impacts of droughts and heat waves, that's not just going to impact hydropower today and going forwards, but also many other forms of electricity. If we think about coal-fired power, for example, or nuclear, they are also impacted by droughts and by heat waves. They require water for cooling, and we see in France today, for example, that nuclear energy output is being impacted by the high temperatures. And in fact, the government has had to loosen some of the environmental regulations that there are on discharging hot water into rivers to ensure continued operations. But you rightly mentioned the impact of droughts on hydro. Hydroelectricity is today by far the largest source of renewable electricity. We actually get more electricity from hydropower than we do from all other renewable sources of electricity. So wind, solar, geothermal, bioenergy, put all of them together, the amount of electricity we get from them is not as big as the amount we get from hydropower. So it might not always get the headlines, but it is an essential source of electricity at the global level and also for many, many countries. And when we have droughts and low water levels, low hydro generation does have severe impacts. You mentioned a number of cases, and in fact, we also saw it in Brazil at the beginning of last year. Low hydro output led to a large increase in emissions, and it also had global impacts because it was one of the key factors that led to increases in energy prices. Brazil had to start using more natural gas. That natural gas was therefore taken away from other markets. And that was one of the reasons that we started to see increases in natural gas prices around the world. So low hydro has this cascading effect across the whole energy system. And the final thing to kind of bear in mind about the importance of hydro is that it's not just about the amount of electricity we get, but it's also a key source of flexibility. For decades now, hydro has helped to manage the fluctuations that there are in electricity demand. Whenever there's a sudden increase or a sudden decrease in electricity demand, hydro has been there to help us smooth out those fluctuations. And we need it to continue to play that role. It's going to be ever more essential going forwards as we have more electricity coming through from wind and from solar. You rightly mentioned that there are no direct emissions from hydroelectricity generation. It's one of the key forms of low emissions, flexible generation. So when we look forwards, look ahead to the necessary goal of achieving net zero emissions as soon as possible, hydro absolutely has to be an essential part of that. And we need to make sure that whenever we are building new dams or managing existing dams, that we are able to ensure that we have that baseload generation and that flexibility going forwards.
Thank you for that answer, Dr. Christoph McGlade. Dr. Tira Mustonen, I think it's a really pertinent question. And also another question that's been thrown in there is, what about the potential methane emissions from hydro as well?
Well, thanks all. And Zaya, thanks for the question. While Christoph was outlining many of the correct benefits of generating electricity from hydro dams, there's also a rising environmental action and scientific remedy to take down dams, especially the old dams or unlicensed dams or ineffective dams. So there's a rising school of thought, especially, for example, in the US on dam removal. And when we are looking at the ecological impacts and climate impacts of hydropower, there is methane that's being generated from the reservoirs, especially in the early years. Also, when we look at the whole number of dams, for example, in the US, like Mark is outlining, it's about 80,000 dams. And most of these dams were built over the past century with horrible impacts on migratory fish, ecology, and so on. There's also the question of mercury leaching when the reservoirs are young in their ecological time frame, and we can say the river system is in a shock. So there's a couple of points that are now pertinent in the conversation about hydro and climate. I have been involved in dam removal and restoration of river systems for the past 20 years around the world. And we can see some of the gradients of how things could move forward. And I'll just point in a very quick way, a couple of them. One of them is that we have a number of critically important and often endangered biodiversity. such as salmon stocks, which are still wild, or in China, we know the impacts from the Three Gorges Dam. And therefore, we need to think what kind of hydro dams and where are we putting them. In most of the cases with the modern dams, we could now create side flows and better technologies for the generators that no longer plug the whole river stream and would alleviate some of the worst environmental impacts if we have to make a dam. Secondly, the question of river basins. Now that we are in this drought and extreme events, a lot of those events are the result of massive alteration to the catchments and river basins that have no longer the capacity to store water, especially things like marsh and peatlands. Finally, the question of human trauma and impact from past dam removal has become clear. We have now scientific evidence of dam refugees, forced relocation of villages, cities, indigenous peoples. For example, the ongoing trauma in Columbia and Snake Rivers in the west coast of the US. So in the question of dams, it's not only about the benefits, it's also what could we do to upgrade past and, shall we say, partly dysfunctional old dams into restored systems, enable biodiversity comebacks, for example, nutrient flow from the Pacific Ocean into the rainforests in the west coast of the US, and many other things. And this should be topical when we are discussing new massive dam programs, for example, on the Mekong and in Southeast Asia, which is ignoring many of these lessons learned. Thank you very much.
Thank you, Dr. Tira Mustonen. It seems that it's a question of balance. You know, we know hydroelectricity is important, but it's how we balance the pros and the cons of it moving forward that I think is going to be something that we need to do. And you know, with the knowledge that we have, it's so important that we continue to use these alternative sources of energy as well. Zaya, how are you feeling with that? Were you happy with those answers?
Yeah, absolutely. I think it's important that we have a nuanced look at, you know, energy sources and where they're going in the future. My jaw has dropped over the past summer, just seeing how many rivers have been drying up. And I am concerned, deeply concerned because here in Canada, it's our primary source of clean electricity. Here in Ontario, even more primarily in British Columbia, where my family lives. So while we have the benefit of having glaciers and meltwater here in Canada, and our hydroelectricity is not at stake at the moment, we also know what's happening to glaciers and snowpack melt. So that's coming down the road as well. So a lot of those feedbacks are just a little bit scary to think about.
Indeed. Thank you once again, Zaya. Next up, we're going to go to Professor Hugh Hunt, Deputy Director at the Centre for Climate Repair at Cambridge. Hugh, we've been talking about the possibility of refreezing the Arctic with CCAG for some time. I mean, it sounds like something from a science fiction movie, but I understand you're the expert on this, and I'd love to hear more about the project. As I said, it sounds absolutely fascinating. And if done right, does refreezing the Arctic together with remove and repair give us a realistic opportunity of halting and reversing the Arctic tipping point? Hugh.
Well, thanks very much for having me on today. Let me just first say that the very fact that we're even thinking about something as mad as refreezing the Arctic means that we've gone very wrong. We shouldn't be in this position at all. But we've got to stop burning fossil fuels. That's a given. And we've got to get the levels of greenhouse gases out of the atmosphere, the ones that we've already put in over the last couple of hundred years. We've got to reverse that trend. So from our Centre for Climate Repair's point of view, reducing emissions and removing greenhouse gases are kind of the two things we've got to be concentrating on. The third thing, which is about climate repair and about refreezing the Arctic potentially, is, well, the Arctic is one of the biggest tipping point locations, the biggest tipping points on the planet. The Arctic is warming 3 times faster, perhaps 4 times than the rest of the planet. So we're really looking at ways of reflecting sunlight by perhaps brightening clouds in the Arctic to try to stop them melting in the summer, and perhaps also spraying water onto the ice in the Arctic to try and thicken the ice in the winter. So really, in answer to your question, we think we can find ways to refreeze the Arctic, or at least to slow down its rate of melting. But research has to be done. It can't be done just by computer simulations. It can't be done with pencil and paper. We've got to be doing experiments with marine clouds in the Arctic and experiments with thickening ice. And that's what we're really trying to do with our Centre for Climate Repair as quickly as we can, because time is running out. The technologies are at their infancy, but they are really worth exploring. So I don't know whether that's enough to go on for now. I'm happy to say more if you wish.
No, I think it's really important. And your point at the beginning, I think, is the most important, in the fact that we have to stop burning fossil fuels. We can't be relying on these kind of technologies, and they're almost like, feels like last desperate things that we can do to repair our climate. But yeah, thank you, Hugh, for that.
Can I just perhaps just to add that the scale of infrastructure, the technologies that we've developed to burn fossil fuels and to mine for coal and to extract oil and gas, if we're willing to do even 1/10 of that kind of infrastructure in order to try to refreeze the Arctic, we can do a huge amount. So all I would say is that we know how to do engineering on the large scale to burn fossil fuels. Why can't we do even just 1/10 of that to try to preserve the Arctic? That's my sort of remark on that.
Yeah. I mean, if we're going to use that amount of energy to make profit, we might as well use that amount of energy to try and save our planet and our atmosphere. So, Dave, I saw you had your hand up there quickly.
I thought I'd just add to what Hugh was saying, that if we don't do this, if we don't learn and act on refreezing the Arctic, we are faced with a future which looks pretty awful, because Greenland is sitting there in the Arctic Ocean during the polar summer. And this means that Greenland is now melting, its ice is now melting irreversibly. Sea levels globally would rise in total by 6.5 meters, 23 feet, goodbye London, etc., when all of that ice has melted. Now, it may take a while, but even a couple of meters is going to be a dramatic change in the map of the world. If we also look at the permafrost region around the North Pole, we know that it contains a vast amount of methane. And there is a good possibility that if we allow this heating to continue, that methane will be released in a short period of time, and temperatures would then rise globally by perhaps 5 to 8 degrees centigrade. So what I'm talking about is the importance of us being able to refreeze the Arctic in order to avoid these dramatic challenges to our existence.
Yeah, thank you, Sir Dave. I'm very aware that we've got many questions on today's panel, so I'm going to up the pace a little bit. And Hugh, I know you have a question for our panel. Fire away.
Well, I was very taken by that pretty bleak-looking graph temperature anomaly in Europe. The extreme hot summers that we've been kind of used to soon become the extreme cool summers. I think that was the message. And I guess I'm wondering what we need to be doing now, because this is only 20 years away. What do we need to be doing now to increase the resilience of our medical infrastructure, of our just the general infrastructure? We know that things tend to break down in the heat, and we know that people suffer in the heat. What do we need to be doing now to prepare ourselves for what really is only 20 years away?
Thank you for that, Hugh. Professor Mark Maslin, would you like to kick us off here?
Certainly, and it's a great question, Hugh. I mean, it comes down to actually planning and strategy, which unfortunately isn't something that many governments are good at. And we can actually look at best practice. So the French were incredibly shocked by the death toll due to the 2003 heat wave. We lost 70,000 people in Northern Europe during that one heat wave. And therefore, they basically realized they had failures in their medical system, and they completely changed it. And we know that the subsequent heat wave in 2007, they probably lost a quarter of the people that they would have lost if they hadn't changed. And these were simple changes. Firstly, they found out where the vulnerable people were in their cities. Really important. Secondly, they set up places where there was air conditioning, and they also provided transport to move people there. They also provided a warning system to warn people, because what had happened during that heat wave in August is all the young people and all these sort of like people had gone on holiday and just left all the old people to basically fry to death in the heat wave. So we can learn from that. So we need to actually think about who are the vulnerable people during heat wave. It is mainly the elderly, and it is particularly nighttime temperatures that we have to reduce when they're asleep. Because during the day, they can hydrate, they can move around, they can actually aerate themselves. But it's at night when they go to sleep, their bodies cannot control their body temperature. And if you don't get the temperature down in their bedroom, that's when they can pass away due to the other underlying complications. So some simple things. Perhaps in the next 10 years in Northern Europe, we could have laws that says all old people's home have to have air conditioning. Okay. Now, again, we say, oh my word, air conditioning, that's going to be terrible. Well, hang on. How about we actually move away from all the gas central heating, and we actually have a system where we're moving to heat exchangers? That means that we can cool the buildings down during the summer, but we can also heat them in winter, and we can do it with electricity, we can do it efficiently, and therefore we're not burning gas. So I think there's lots and lots of really good ideas that we can have, and we can take from other countries that have dealt with these sort of temperatures. But I just want to emphasize for everybody how the peak heat waves are. So for example, as Peter knows, sort of like the average temperature, peak temperature for July is 22 to 24 degrees in the United Kingdom. You know, that's nice. You know, that's a nice peak temperature. We have peak temperatures of 40 degrees. That's 16 to 18 degrees warmer than it should have been. This is shocking. This is like beyond what many of us climatologists were expecting. And I think we need to put that in context, because you're talking about warmer summers in the future. What I'm worried about is not just the warmer summers that Peter's modeling beautifully, but then the heat waves on top of those, because it's those short, sharp events, couple of days to a week. Those are the things that actually kill people. And basically people don't get that actually heat waves are killers.
Yeah. Thank you, Professor Mark Maslin. Absolutely fascinating. Alice Hill, would you like to chip in on this as well, please?
Sure. Well, thank you. Absolutely. Heat is one of our most deadly natural disasters, and we are not prepared for the temperatures we're seeing already, much less those that will come in the future. It is, as has just been said, about planning and putting in place, first of all, emergency responses. So we need better forecasting of heat waves. We have efforts across the world to now name heat waves to signal how significant they are in terms of the risk to human health, also the risk to animals, crops, and as been stated, our infrastructure. We also need to make sure that socially vulnerable, the elderly, often men living alone, are warned of what's ahead, and then the dangers that can cascade through the human body with exposure to heat. We'll need to change our labor laws in many areas so that people aren't outside as long, because that is a threat to them. And then we have a lot of built environment. Here in the United States, we only change over new development about 5% a year. So we need to retrofit what we have, and then we need to build new buildings that allow, for example, for ventilation, should the power go out. So these tall skyscrapers that we have where the windows can't open, elevators won't work. That's very dangerous. We also need to look at new materials, such as white pavement for roads that reflects the heat back up. We have here in the United States white roof requirements so that the roofs aren't absorbing as much heat going forward. And we'll need to look at things like changes to clothing and how we can all be better outside. We're just at the beginning of this, but we're running out of time because we're being surprised at how extreme, we shouldn't be surprised, the scientists have told us, but the planners are surprised at how extreme these events. So we need to look at the emergency response and then the long-term, how will we survive these longer events?
Alice Hill from the Council on Foreign Relations, thank you very much for that. Peter Starr, I'd be really interested to hear your thoughts on this as well, please.
Yeah, and just picking up on the point that Alice has just made, actually, and following from what Mark said about we can't use the past anymore as the guide to the present, actually. So as Mark said, we'd never seen anything near 40 degrees before. We published some work on this, actually, that showed that it had become a risk. But although that we could forecast it on weather timescales pretty accurately a week ahead, if you look back on the climate timescales, you would say that 40 degrees was a remote possibility. And yet here it is with us. As Mark says, this is weather that's way outside our normal expectation. So really the main point I want to make here is that we can't use the past as a guide even to what's happening now. We've got to use our best endeavors. And as I've shown, the climate models have been pretty accurate at simulating past summer temperatures. But then we've got to add to that our developing understanding of what that means for these extremes, for these very extreme heat waves, for these droughts, for these floods, flash floods. And I think here the emerging science is showing us that actually the situation is actually more worse than we thought. And we talked about the Arctic, the effects on the Arctic of the weather in mid latitudes as well. So we've got to bring all this science together to really show about these rapidly developing risks and bring this information together to really change very rapidly how we become more resilient, as Mark and Alice have just outlined. Because as I showed in those graphs, things are changing really, really rapidly in terms of our climate and how that affects our weather. So it is a very urgent and important issue to address.
Thank you, Professor Peter Starr. I mean, it is really scary when you say we can no longer use the past for references of the future. It just means we're moving into completely new and almost unknown territory, which is so scary, and it makes it even more urgent. Hugh, thank you so much for that question. We're going to move on to our next guest, Nyombi Morris. Nyombi, it's great to have you with us once again today, and we'd love to hear your perspective on this question and then your question for the group.
I didn't hear the question. Maybe you can repeat. Thank you so much for hosting me.
Sorry, Nyombi. First of all, thank you for joining us once again today. But we'd also be interested to hear your perspective on the extreme weather that we are now faced with, and the future that we have to deal with, and then your question to the panel.
Actually, for me, I think in Uganda this has become normal, and what we are receiving today is we are seeing unpredicted, deadly, and devastating impacts across the horns of Africa. We are seeing wildfire in Algeria. We saw cyclone in Mozambique. We saw floods actually this very year in Sierra Leone. It has never happened. We are seeing starvation for Uganda. Actually, it is very, very difficult. Like in July only, we lost over 900 people due to starvation. 43 were actually counted as kids, like 43%. And I'm wondering, how are we going to overcome? Because one, we are having difficulties in accessing finance as much as this is going on. And even when that finance comes in, most of it goes into mitigation more than adaptation, whereby our countries heavily rely on irrigation and agriculture. So my question comes in is, how will we transition to adaptation and put it in place as soon as possible if world leaders and policymakers fail to approve the laws and damage funds at the Egyptian conference? As Africa, we intend to embark 2 missions. One, a complete phase out of fossil fuel subsidies, which is what got us into this mess. And the second one is show us the money. We need climate finance to rebuild better. But our question is, what if we fail? Is there any other option? Because last year in Glasgow, we failed. And this year, we are just trying. But what if we fail? Do scientists have any other advice? Because we need to rebuild. Our people are dying and climate change is happening today in Africa. Thank you.
Oh man, so stark, Nyombi. Thank you for sharing that with us and giving us the reality of how climate change is hitting real people in the continent of Africa, in Uganda especially. Professor Mark Maslin, I saw you had your hand up there, and perhaps Sir Dave King can go after that as well.
I was also hoping some of the economists would step in, because my money knowledge is not as good as it should be. Firstly, I wanted to say that great disappointment with COP26 in Glasgow was loss and damage was not agreed. However, I think the interesting thing is that isn't a huge amount of money. Okay, we think of the 100 billion that's promised as being a lot of money. It isn't. What we need is mobilizing huge amounts of money to actually support and help Africa develop. We actually need it in the economy. Instead of being gifts or being sort of like backhanders from sort of like rich nations trying to actually get their own companies the best products and the best sort of like deals, I think we need to actually step up. So again, I completely agree with you. Phase out fossil fuel subsidies. Develop African industry, make sure that Africa can actually build its own renewable energy, make sure it's actually becoming self-sufficient. It can also then think about how Africa supports Africa, because again, the interesting thing is so much diversity, so much talent, and so much sort of like energy is there. All the countries should be working together as a bloc. And I think this is the interesting thing we're going to see in Egypt at COP27. COP27 has said that one of its major aims is to put adaptation front and center. So it will be equal with mitigation. Absolutely. We have to reduce global emissions. We have to stop burning fossil fuels. Hugh said this, everybody says this. We know mitigation is important, but we've also seen with all the extreme climate events in Africa, in Europe, in China, North America, we also have to adapt very quickly. So I think focusing the world's minds at Egypt in COP27 on adaptation will be really important. And I think what we also have to do is use that as a vehicle to actually talk to the money, talk to the banks, make sure that they understand that actually infrastructure projects that provide fresh water, that actually provide renewable energy are important, and they shouldn't charge higher interest rates just because it's Africa.
100 billion is nothing when it comes to saving the human race. I mean, it's just absolutely nothing. Thank you for that, Professor Mark Maslin. So Dave King, love to hear your thoughts, and perhaps could you give us a quick explanation on what we mean by adaptation as well?
Adaptation is exactly what we are now discussing. We are seeing new weather systems, unexpected weather systems, unexpected if you don't take note of the modeling that, for example, Peter has presented. So what we're talking about is adapting to a new climate system around the whole world. And that adaptation is a challenge to not only every country, but every region of the world. And in every region of the world, the challenge will be somewhat different. What I did want to say, and I very much welcome Nyombi's question, What I did want to say is that the Climate Crisis Advisory Group has put out a report in which we've been very critical about the loss of trust between the developed world and the developing world. And that loss of trust is so apparent amongst the negotiators. That is why loss and damage was thrown out at COP26, but it was thrown out well before that, back to COP18. We've seen this discussion being thrown out by the developed world because it seems like a loss of their cash going off into the developing world. So I think what we are actually saying, and I'm not saying anything different from Mark, what we're actually saying is that this is a global problem and it requires a global response. It means that Africa is a part of our world and we're all in this together. And therefore, we need to see that we treat it as a global problem. We've walked into all sorts of difficulties with the, may I say, much lesser problem of COVID-19 because we were trying to treat it as a local problem and it was a global problem. Disease knows no boundary. We should also realize that climate change is exactly that. When Africa is impacted by not having the capability, the funding for adaptation in addition to development, then of course we suffer as well. We're all in this boat together. So I do think, and I'm really making a very broad appeal here, that we need to treat ourselves as one world. And until we get to that position, it's very difficult to see that we're going to achieve a manageable future. And let me just phrase that slightly differently. If we don't work together, and let me say the United Nations is the feasible body, but it's not operating in that way. If we don't work together, what will happen is that the world will split up into separate camps. And the separate camps will be involved in wars with each other because the separate camps will be protecting whatever they feel is their due in terms of they have some resource that other parts of the world don't have, so they just block the transition of those resources to other countries. I think what I'm saying is the future looks very bleak if we don't all pull together as humanity to create a future for humanity into the next century.
So David King, thank you for that absolutely brilliant contribution. Tira Mustonen, would you like to chip in on this as well, please, Dr. Tira?
Thank you. Very quickly. All of this complexity that Niobe was talking about also comes to a head with an example from Nigeria. And just to highlight what's adaptation on the ground, the Western rainforest in Africa is found in Ekuri forest. It's a small indigenous community in northern Nigeria, and it's about 33,000 hectares of remaining high biodiversity and climate resilient ecosystems. However, most of the forest is being maintained by the local community against, or shall we say, in the context of adverse impacts by the state officials and federal decisions, for example, to construct a large highway exactly through the last remaining rainforest in Nigeria. And that's why the questions on Africa are extremely important. I thank Niobe for this, and we are marking it as a central importance, I'm sure, through the panel, but it's extremely complex from the outside to create solutions such as the Ekuri forest, maintaining it, supporting it, and protecting it when the state says to the outside, give us money for infrastructure and climate action, and internally imposes on those very last remaining ecosystems that are upholding a lot of the solutions on adaptation and survival. Thank you.
Thank you, Dr. Tira Mustonen, and thank you, Nyombi, for that great question. I mean, for me, what strikes me is we need global solutions. We have to constantly, as Sir Dave said, think of all our solutions to this as global, not just country to country, not as a competition. You know, we are all in this absolutely together. Okay, let's move on to our final guest, John Paul Joes. John, we're delighted that you can join us, and it'd be great if you could introduce yourself and give us your thoughts on this topic, and then ask your question to the panel.
Thank you, CCAG, for this invitation. So my name is John Paul Jones. I am from India. I'm a climate activist, and also I hail from the agriculture community. And for a long time, we have been fragmented throughout this region due to like historic reasons like colonialism and on. So we have been on move due to various reasons. And ever since we began to practice agriculture, everything used to be normal until we reached a point where we are in now, that is extreme weather events. So so far, we have been following the nature and the climate in a very positive way, making our own adaptations and mitigations to deal with nature to have a harmonious relationship. But recently, like if I could recall, since 2018, there is no year without any extreme weather events here in Kerala, because the place itself is one of the most ecologically fragile and climate sensitive region. At the same time, we are like seeing larger impacts on the people dependent on nature. So as you all know, India itself is a country that is highly dependent on agriculture. That is more than half of the population is dependent on agriculture. And if you just look back the last 4 months, like we have seen a heat wave, and now we are witnessing floods in the northern part of India. At the same time, southern parts of India, that is Kerala, where I live, in the month of July end and first week of August, we have seen the extreme rainfall leading to floods. At the same time, within a week, almost most of the rivers dried up. And again, we are experiencing another flood situations. So in a short span of time, we are seeing a huge change in everything that is happening around. At the same time, there are various factors that is assisting this progress, and one thing is land use changes. For instance, the government had actually dredged the rivers, saying it's a flood control, that ended up drying the rivers. At the same time, they have opened up the dams and saying there is a matter of flood control. So do we really need science in every thought or every discussions when we understand extreme weather events, and also when we respond to extreme weather events? Additionally, someone from agriculture community, so we have a certain way in which we deal with our land, environment, and also see the future. And that is common with millions of people, because there are like millions of ways in which nature is managed and live and see nature for livelihood. At the same time, due to extreme weather events, we are in a crossroad, because the ways in which we think about nature and we make use of nature is impacted. So do we need science to move forward? Or do we need finance to move forward? Or do we need adaptation, resilience, and mitigation to assist to continue our livelihood and our activities with the environment? And the last thing is, because if we don't continue our relationship or continue our livelihood and tradition, it's a knowledge kill, it's a tradition kill, and it's an environment kill, because there are industries looking to get our lands because they want to mine the land further, and we get displaced to huge housing complex and everything, because a farmer or fishing community has nothing to do with a closed gated community unless there is no access to land or sea. So how do we see these situations? How do we make people to continue their culture and make the government to deal with extreme weather events in a more scientific way?
John Paul Jones, thank you very much for that question. And I think it very much underlies the complexity that we have when it comes to dealing with the climate crisis. I'm going to throw this first of all to Professor Mark Maslin.
So, John Paul, thank you for your incredibly important question, because I think many of us forget, particularly urbanites who live in cities, we forget that farmers are in many places in the world the custodians of our land. They don't just grow food, which is absolutely essential to feed the growing population of the world, but they also basically look after the soils, they look after the biodiversity. And we can see that effect in the 1990s. We actually, when we were looking at the whole globe, we saw that there was actually some greening. And that was mainly in India and China, as Chinese farmers basically started to reforest parts of Western China. Same with India. And I have to say, I think the question comes down that you're asking is about who looks after the farmers. Because I have to say, the farmers, particularly in India, have gone as far as they can. They've adapted, they've taken on new technologies, they've taken on traditional knowledge about how to deal with extreme climate events. What we need now is, I would say, larger strategies at the regional level. We need to think about how do you provide water during drought periods for the people, but also for the farmers, so they don't lose their crops. We also then have to think about how do we actually produce enough fertilizer to make sure that the farmers are able to maximize their productivity while looking after the land. We also then have to think about what crops should they be growing, and can we actually use science to suggest that perhaps some farmers may want to swap to other crops which are traditional but maybe growing slightly better. Also, we need to think about what infrastructure, and this is, farmers can't influence that, but this is at governmental level. You say, well, hang on, we're getting more droughts and we're getting more floods. How do we actually put the two together? How do we ensure that that extra water that we're getting, we can store, we can build lots of infrastructure to make sure that we can then use that during droughts? And I think it all comes down to government and local government and national government saying, hang on, agriculture is the backbone of almost all societies in the world. How do we protect the farmers? How do we make sure that they have a livelihood, and we make sure that they can actually still be productive when we're having this changing climate? So for me, yes, science should be right in the heart of government all the time, saying these are the changes. This is what's going to happen. So for example, Peter's work, when he's going to do the same as he's done for Europe, when he does this for India and China, that's an incredible piece of policy, because the policy makers can then take that away and go, okay, this is the sort of summers. How do we protect the farmers in Kerala? How do we actually protect their livelihoods? How do we make sure that we still have farming as part of the fundamentals of our economy?
Thank you very much, Professor Mark Maslin. I mean, we should be using every tool that we have available to us in the human race to deal with this climate crisis. And science is part of it, but also the social sciences are the part of it as well. It should all be in there. Can I go to Professor Lorraine Whitmarsh as well? I'd like to hear your thoughts on this, please.
Yeah, thanks, Ade, and thanks for the question, John Paul. I mean, Mark gave a great answer, but I just wanted to elaborate on a couple of points. I think absolutely we need insights from science and social science on this, but as you've touched on, there is huge amounts of practical expertise and knowledge embedded within communities of practice amongst farmers. Some of that is very ancient indigenous knowledge, some of it is through sort of trial and error more recently as to kind of how to adapt to these rapid changes that we're all experiencing. And what we know from sociology of science is actually that where scientists have sometimes come into communities with the solutions that they think will work, and they've not engaged with those communities, including farmers, and they don't know the local context, sometimes those solutions are not the right ones for those areas. So it is really important, I think, for there to be both scientific insight, but absolutely engagement with farmers and with local communities to know, what works in that situation and what are the needs and insights that they have. So I think a balance between science and other forms of knowledge is really vital. I think, and also just to touch on the point about that Mark made around the importance of policy here, and actually thinking about food systems and land use more widely, the need that actually to really radically change the way in which we kind of our relationship with the land and with the natural environment. And we're seeing changes on the demand side as well as on the kind of the supply side with what farmers are doing. We know that consumers are already starting to change their diets and to think about food waste and to think about moving towards plant-based diets. But we need much, much more change on the demand side than we're seeing at the moment. And we need that to be pushed also by policy. So we need much more, I think, intervention to manage this transition within agriculture and land use than we currently have. And we need that to look at not only the supply side, but also the demand side as well.
Thank you so much for that response, Professor Lorraine Whitmarsh. And that's it for us today. It's been another wonderful, insightful, knowledge-filled session, which I really, really enjoyed, and I hope you at home will take a lot from that. I want to extend a particular thank you to the Hadley Centre and Peter for their input into today's session, and of course, thank you to our other guests for joining us. And finally, as always, thank you to our CCAG experts for their time. Thanks to those of you at home for tuning in, and if you have any questions, to get in touch with us on our social media channels, and we look forward to seeing you again at our next CCAG public meeting. Bye for now.
The situation with climate change is clear. The crisis is not being managed in the way it needs to be managed at the moment. I am Sir Dave King. I have set up a climate crisis advisory group. The group represents the international experts on climate change to be available to the public, to policymakers, and to the media around the world. We need action now. What we as humanity do over the next 5 years will, in my view, determine the future of civilization.